Hello, dear student. In previous class, I discussed about the Bohr's atomic model. I have discussed about different postulates of Bohr's atomic model. These are few postulates here given. In the second postulate, I have given a formula that is your En is equal to minus 2 pi square m e to the power 4 z square by n square s square. Next, Rn is equal to n square s square divided by 4 pi square m e square z. These are, I have also discussed about the merits or advantages of Bohr's atomic model. It explains the nuclear stability of the atom. It explains formation of spectral line of atom or ions having single electron. Next, I have also covered some demerits of Bohr's atomic model. It fails to explain the spectra of demerits of Bohr's atomic model. I have also given some hints regarding about the Zeeman effect and Stark effect. Next, I have also covered some important point. Actually, we know the actual formula of Rn is this n square s square divided by 4 pi square m e square z, which is equal to Rn. It is called Rn. But if you think about the atom or ions, we can find out the general expression. Radius of nth orbit of hydrogen atom and hydrogen like ion He plus Li2 plus. This is the general expression. Actual equation here we have here if you put the value of mass of electron, charge of electron, and pi value and h value, then this short formula, that is your Rn is equal to 0 into n square by z angstrom. Similarly, if you value of mass of electron, charge of electron, h value, in the actual equation for the calculation of the energy, then you will find En is equal to minus 1312 into z square by n square kilojoule into mole inverse. This is the short expression. Similarly, if you think about the velocity of the electron, this is the short representation. Vn is equal to 2.188 in 10 to the 8 into z by n cm per second. And this is the general expression for the number of revolution by an atom in the nth orbit around the nucleus. That is your 6.55 into 10 to the 5 into z square divided by nq. By using these three short equation, now in this class I explain some problem related to the Bohr's atomic model. Again, I want to repeat the formula. Here Rn is equal to 0.529 square by z angstrom. En is equal to minus 1312 into z square by n square kilojoule per mole inverse. Vn is equal to 2.188 in 10 to the 8 into z by n cm per second. And number of that is your revolution by an electron in the nth orbit is that is your 6.55 into 10 to the 5 into z square by nq hertz. These four expressions are used for the calculation of energy, velocity, and number of revolution for the hydrogen atom and hydrogen atom like ion, that is your He plus Li2 plus. In this class, look at me. Sorry, in this class, I will explain about some problems related to the Bohr's atomic model. At first, I want to move the problem number one. That is your calculate the energy of Bohr's atomic model. Okay, sorry, calculate the energy of Bohr's third orbit in Li2 plus ion. Here, Li2 plus ion belongs to single electron species. That is your 3. Your 2 plus means there are 2 electron already lost, so your only single electron is present. So Li2 plus ion is similar with the hydrogen atom. because hydrogen atom having one electron, Li2 plus and or Li2 plus and also have one electrons. So is used the Bohr formula. Already I discussed that is your what Rn is equal to 0.529 into n square by z square. Rn is equal to 0.529 into n square by z angstrom. This is the unit. Next, n is equal to how much? Minus 1312 divided by n square z square. That is your thing about kilojoule per mole. Next is the velocity. Velocity here we know that Vn is equal to how much? Vn is equal to 2.188 into 10 to the power 8. Here we can think about velocity of 2.188 into 10 to the power 8 into what? Into z by n cm per second into z by n cm per second. Number of revolution by an electron, that is your you think about the formula. The formula is your 6.55 into 10 to the 5. 6.55 into 10 to the 5 into what? Into z square by nq hertz. Z square by nq hertz. These are the four formula I will use in this problem. Look at that here. The our target to find out the energy of the Bohr's third orbit. And the ion is your Li 2 plus ion. If you think about the value of n, your third orbit is given. Third orbit means that is your m cell. For m cell, the value of n is equal to 3. For first orbit, that is your k cell, n is equal to 1. For second cell, that is your L cell, n is equal to 2. Similarly, for third cell, the value of n is equal to 3 and it corresponds to the to the cell, that is your m cell. For fourth orbit means n cell and the value of small n, that is your 4. So here I can say that from the question it is clear that Bohr's third orbit means your n value is your 3. Since Li2 plus ion, here Li2 plus ion is given, we know that the atomic number of lithium is your 3, so your Z value is your also 3. Look at that here again I want to repeat n is equal to 3. Why here n is equal to 3? Because in the question a point is given, that is your Bohr's third orbit. Bohr's third orbit means n is equal to 3. Here Li2 plus ion is given, Li lithium ion having the atomic number is equal to 3. So here the Z value is your 3. Now we know that the formula En is equal to 12, that is your 1312 divided by n square z square. Now put the value of n. Here n is equal to 3. N and z in this equation. Then I will find here minus 1312 divided by 3 square into 3 square. Here z is equal to 3. Here n is equal to also 3. So here I can write 3 square into 3 square. Sorry. 1312 divided by 3 square into 3 square. After solution, it is seen that the value is your 1312 kilojoule more. Here 3 square can be cancelled. The value of En is equal to minus 30. So our target is to find out the energy of Bohr's third orbit in Li2 plus ion. So here I can write, therefore energy of Bohr's third orbit in Li2 plus ion is minus 1312 kilojoule per mole. This is the answer. Next, move to the problem number 2. Calculate the radius of Bohr's third orbit in He plus. Look at the formula here. Rn is your how much? Rn is your 0.529 into n square z divided into angstrom. Again I want to repeat, 0.529 into n square by z. This is the unit. Angstrom is the unit. So for this problem we apply this formula. Look at the question. Calculate the radius of Bohr's third orbit in He plus. Look at that here. Bohr's second orbit is given. Again, I want to repeat the question. Calculate the radius of Bohr's second orbit in the He+I. Here, Bohr's second orbit is given. So here I can say that n is equal to 2. Since helium is given, so here I can write Z is equal to 2. So here I can write n is equal to 2 and z is equal to, we know Rn is equal to 0.529 into n square by z. So here so now I will put the value of n and z here. So here I can write Rn is equal to how much? 0.529 into 2 square by 2. If you simplify, then you will get 0.529 into 2. After multiplication, we can find 1.05 angstrom. So here I can say that the radius of Bohr's second orbit in He+ion is your 1.058 angstrom. This is the answer. Next, move to the another problem. Calculate the velocity of an electron in the Bohr's third orbit He+. Here our aim to find out the velocity. The equation is your what? Vn is equal to 2.188 into 10 to the 8 into z by n same per second. This is the formula. Here we need the value of z and n. From the question it is seen that your Bohr's third orbit is given. So the value is equal to 3. Since here He+ion is given, we know the atomic number of helium is your hydrogen is 1, helium is 2, so your atomic number is your 2, so z value is your 2. Now put the value of n and z in this equation. Here we can find Vn is equal to 2.188 into 10 to the 8 cm per second into 2 divided by, that is your 3. Now if you want to solve, then you will find 1.458 into 10 to the 8 cm per second. This is the answer. So here I can say that the velocity of an electron in Bohr's third orbit in He+ is your 1.458 into 10 to the 8 cm per second. This is the answer. Next, move to the problem number 4. Calculate the velocity in cm per second of an electron moving in the second cell of hydrogen atom, and also predict the number of revolution per second made by it around the nucleus. Two questions I have given. One is calculate the velocity in cm per second. Another is per second made by the electron around the nucleus. From the question it is seen that here hydrogen atom is given. What happened? Here second cell is given. For second cell n value is your 2. For hydrogen atom z is equal to 1. So here I can write n is equal to 2, z is equal to 1. Now put this value in the equation for the calculation of velocity. For velocity calculation we know 2.188 into 10 to the 8 into z by n cm per second. This is the equation. Now put the value of z and n in this equation. Here I can write 2. Here I have written in wrong way. That is your 2.188 into 10 to the power 8 cm per second into z. Actually, this is wrong. I have written in wrong manner. Put the value of z. Z is your look at this step. You are also missing 2.188. 2.188 in 10 to the 8 cm per second. Here multiply with 1. This is the value of z, and n value is your 2. So if you simplify this, then you will get 1.094 in 10 to the 8 cm per second. I want to verify whether 1.88 or 2.188 or 2.88. Look at that. The equation is a 2.188. For the calculation of velocity, Vn is equal to 2.188 in 10 to the 8 into z by n. Now move to the problem. So after solution of this portion, I will get this 1.094 into 10 to the 8 same per second. This is the answer. Now move to the other question. Number of revolution per second. Our second target is find out the number of revolution per second. The formula is your what 6.55 into 10 to the 15 into z square divided by nq, that is your hertz. This is the wrong position. Now put the value of n is equal to 2, z is equal to 1 in this equation. Then we will find 6.55 into 10 to the 15 into 1 square divided by 2q hertz. So if you calculate, then what will be the answer? That is your 6.55 into 10 to the 15 into 1 by 8 hertz, that is your 0.818 hertz. So the required velocity is your what? 1.094 into 10 to the 8 same per second. This is the answer. And the number of revolution per second is your 0.818 hertz. This is the second answer. I want to check what is the formula for the calculation of number of revolution. Look at me, look at that. Here 15 is given. If you calculate, what will be the answer? I want to verify whether this is correct or wrong. 6.55 into divide by what? Divide by 8. That is your how much? 0.818. Here 15 is missing. Again, I want to check the original file. Exactly what happened, what is the wrong, I want to check. Number of revolution. Look at that here. That is for 6.15. So exactly what happened. This is the correct the 15. 6.5 15. That is your z square by nq. Number of option here actually wrong question, wrong answer is given. Actually, here also something wrong. What will be the answer? I want to verify. Yes, that is missing 10 to the power 15. If you solve what 6.55 divide by 8, then you get 0.818. Yes, that is missing. Here, the answer is your 0.818 into 10 to the power 15. This is the answer because here there is missing of. If you divide, if you will do the work like 6.5 divided by 8, then you will get 0.818. Next, there is also another term 10 to the 15. So here I can write the answer is 0.818 into 10 to the 15 hertz. This is the answer. Okay, here also I can change. Answer is 0.818 or 15 hertz. This is the answer. The number of revolution per second. These are few problems I have given in this class. Next, it is highly remember to this such type of relation. Here it is compulsory to remember this. Here E is electrovolt. So here I can write 1 electrovolt is your 23.0609 kilocalorie per mole. Second is EV is equal to 1 EV is equal to 96.4869 kilojoule per mole. 1 EV is equal to 2.41804 into 10 to the 14 hertz. 1 kilocalorie per mole inverse is equal to 4.184 joule per mole. 1 EV is equal to 1.6021 into 10 to the minus 19 joule, which is equal to 1.6021 that is 10 to the minus 16 kilojoule. This is the relation necessary to remember. This is all about Bohr's atomic model and some problem. Next, I will teach you some new concept, that is your concept of atomic number and mass number. Actually, what is atomic number? What is mass number? Let me explain. The number of proton present in the nucleus is called atomic number. Listen, suppose if you will take an atom, here nucleus is present. Nucleus is made by proton plus neutron, and the electrons are surrounding around the nucleus. We know that number of proton is equal to number of electron for an atom. For an atom, the number of proton is equal to number of electron. But for an ion, we cannot say that number of proton is equal to number of electron. It is wrong. So always, if you think about the proton, then proton for ion, that is your whether positive ion or negative ion, proton always. Sorry, actually I want to say that if you think about the atom and positive ion, negative ion, then for all the case proton remain constant. Proton will not change. Only electron will change. So for atomic number definition, we can say that number of proton present in the nucleus is called atomic number. Remember, here we cannot say that for all the case number of proton is equal to number of neutron. It cannot be possible. So simply we can say that number of proton present in the nucleus. How many number of proton present in the nucleus? That is your atomic number. Suppose 6 proton is present, then the this species is your 6. Here 5 for proton is present, then it is called atomic number is your 5. So here I can say that number of proton present in the nucleus is called atomic number. For neutral atom, here we can say that atomic number Z is equal to number of proton, P is equal to number of electron. Already I have told you. For an ion, the number of proton in an ion is equal to atomic number. Number of proton in a ion, we can say that atomic number for an ion. But remember, you cannot say that for an ion, the number of proton is equal to number of electron is equal to atomic number. This cannot be possible. For an atom, we can say that atomic number Z is equal to number of proton, P is equal to number of electron, E. But for an ion, the number of proton in an ion is called atomic number. Similarly, if you think about the mass number, already you know atomic mass. In the first I have already discussed what is atomic mass. Now a new term is given, that is your mass number. Do not think that mass number and atomic number are same. The value in sometimes may be same, but for all case it is not possible, because atomic mass and mass number are different. Here we can say that the sum of neutron and proton is called mass number. That means P plus n is equal to, that is your mass number. Mass number is for an element x. Suppose an element I have taken, that is your x. Its atomic number. Atomic number is your Z, mass number is your A, then the element can be represented like this. Here X is the element, Z is written in the bottom, A is written in the top. So here you can say that XZA, that is the actual representation of an element with atomic number and mass number. Now move to some problem related to the atomic mass and mass number. Problem number one: how many electron, proton, and neutron are present in the following nuclei? Here N is N 714, L 3 plus 13 27, Br minus 13 35 80. Three species are given, and it is target to find out the electron, proton, neutron. At first, I want to move N714. Look at that. Already I discussed if the element X and atomic number A and atomic number A and mass number is your Z. Sorry. Here, yes, atomic number is your Z, mass number is your A. For an element X. Here we can write XZA. This is the symbol. So if you will compare here XZA, here we can say that 14 is the A, Z is the 7. So here I can say that mass number A is 14, and that is your atomic number, that is your Z is your 7. From this representation, here we can say that 7 represents the atomic number and 14 represents the mass number. Now our target to find out the electron. As per the definition, if you think about the definition, for a neutral atom, atomic number Z is equal to number of proton is equal to number of electron. Here atomic number is your how much? Atomic number is your 14. So number of proton is your also 14. Number of electron is your also 14. Again we know that mass number A is equal to 14. Mass number A is sorry. In this question, atomic number is your 7. So here I can write for neutral atom, atomic number 7, number of proton is your 7, number of electron is your 7. Mass number A is given, that is your 14. For calculation of mass number, we know the formula. Mass number A is equal to what? P plus N. Here we can say that number of proton plus number of electron is your what? 14. 14 is the mass number. Now put the value of number of proton. That is a proton having value, that is your 7. So here I can put the value of number of proton, that is here I can put 7. Then 7 plus number of neutron, or we can write number of neutron plus 7 is equal to 14. Number of neutron is equal to 14 minus 7, that is your 7. So for N714, here we can say that number of proton is your 7. Number of electron is also 7. Is also 7. This is the answer. Move to the another species, that is it is a positive charge. Here 1327 L3 plus. This is said to be mass number. This is said to be atomic number. Again I want to see the representation, that is your XZA. So here we can say that atomic number, Z is your what? 13. This is your 13. And A is your what? 27. So your mass number, that is your 27, is your A. Atomic number, that is your, find out the electron, number of electron, number of proton, and number of neutron. This is our target. For a neutral atom, atomic number Z is equal to number of proton P plus number for atomic number Z is equal to for atomic number Z is equal to number of proton P is equal to number of electron. Since here you can say that atomic number that is your Z is equal to 13. So here I can say that atomic number Z is equal to 13. Number of proton is also 13. Number of neutron is also number of electron is also 13. Look at that. For neutral atom. For neutral atom means here we can say that is your for an aluminum atom number of electron is 13. But if you think about the Al3 plus, what is the difference between Al and Al3 plus? Here Al loses 3 electron and it converted into Al3 plus. This is the difference. Here aluminum having 13 electron. It loses 3 electron, means Al3 plus having 10 electrons. So here I can say that number of electron is equal to 13 minus 3, that is your 10. Now move to the mass number. Mass number, we know that mass number is equal to number of proton plus number of neutron. That is equal to 27. Number of proton already I calculated. Number of proton is how much? Number of proton is 13. So put the value of 13. 13 plus number of neutron is equal to 27. Number of neutron is how much? 27 minus 13 is equal to 14. So the answer for Al3 plus is your number of electron is your 10. Number of proton is your 13. Number of neutron is your 14. Look at that. Here proton and neutron are not having equal value. Proton having 13, neutron having 14. Next, move to the another problem, that is your Br minus 80 50. Again, remember the general representation, that is your XZA. So here A value is your 80 and here we can say that A value is 80. B value is your Z value is your 35. A value is your 80, Z value is your 35. So here I can write mass number Z is equal to mass number is equal to 80. That is your A value. Atomic number Z is equal to, that is your 35. We know, again apply the same concept. We know for a neutral atom, atomic number Z is equal to number of proton, P is equal to number of electron. Atomic number is your how much? 35. So here I can write atomic number is your 35. So number of proton is your also 35. Number of electron is also 35. So here I can write down number of proton is your 35 and electron for Br is your 35. For Br, the number of electron is your 35. For Br minus means you have added 1 electron, that is a 35 plus 1, that is a 36. What is the difference between Br and Br minus? When bromine gain 1 electron, then it will convert into Br minus. Your bromine is having 35 electron. Add 1 electron means that is your the total electron for Br minus, that is your 36. Again apply the same formula. Number of proton plus number of neutron. Number of proton plus number of neutron is equal to mass number, that is your 80. This is to be mass number. Clear? Now put the value of number of proton. Number of proton means your 35. So here I can write 35 plus number of neutron is equal to 80. Now find the number of neutron. Number of neutron is your how much? 80 minus 35 is equal to 45. For Br minus ion, the number of electron is your 36, number of proton is your 35, and number of neutron is your 45. This is the answer. Next problem, determine the number of nucleons in an atom of U 92 to 35. Atomic number, this is the mass number. So mass number here I can say that 235. Number of nucleons. Nucleons means the total constituent present in the nucleus. This is your nucleus, and this is the space in which electrons revolves around the nucleus. Nucleus is made by neutron and proton. Electron is present outside the nucleus. Now, here neutron is one nucleon. Proton is also nucleon. Total nucleon means n plus p. So mass number is your 235. We know that number of proton plus number of neutron is your how much? 235. From the this is the value. U 92 235. This is the atomic number, and this is the mass number. Mass number denoted by A. Atomic number is denoted by Z. Clear? Mass number is your 235. Mass number means number of proton plus number of neutron, that is your 235. We know that n plus p is your said to be total nucleon. Clear? This is said to be total nucleon. So here I can say that number of nucleon is your 235. So the answer is your number of nucleon is your 235. This is all about atomic mass and mass number. Now move to the another important topic, that is your nuclear structure. Already I have given some hints in the first chapter what isotope regarding about the isotopes. What is isotopes? The atoms having the same atomic number but different mass number are called isotope. Look at that. Here some examples are given. Hydrogen having three isotopes. One is your protium, deuterium, tritium. Protium, that is your H11, D12, tritium 13, T13, T13. Look at that. This is the atomic number. This is the atomic number. Look at that. One is present here. One is present here. One is present. So here I can say that the atomic number is for all case. It is your one. In all the case equal. Yes or no? But if we think about the mass number, here for hydrogen one is given, here 2 is given, here 3 is given. The mass number for the three species are not same, but the atomic number for all the three species are same. If you think about the species, the three species are called isotope to each other, because as per the definition, for detecting the isotope, you clearly think about the atomic number and another is the mass number. If atomic number for all the case are same, but the mass number is different, that are called isotopes. So here we can say that isotopes of hydrogen, there are three. One is protium, deuterium, tritium. If you think about the isotope carbon, here I have given three isotopes. Look at that. C612, C613, C614. Here 6, here also 6, here also 6. But the mass number first is your 12, second is your 13, and third is your 14. But atomic number 6, 6. Here the atomic number is the same, but the mass number is different. So here I can say that C612, C613, C614 R3 are called isotope. Exactly, if you think about the isotope of carbon, carbon has 15 isotope. Carbon has 15 known isotope from C8 to C22. But among the 15 isotopes, only C12, C13 are stable. Similarly, if you think about the isotope of oxygen, here two isotopes are given. One is your O816 and another is your O817. Here atomic number 8 for first case, for the first that is your O816, and atomic number for O817 is your also 8. But if you think about the mass number, here 16, here 17. The mass number are different, but the atomic number are same. So there are two isotopes for oxygen. One is your C816, another is your sorry. There are two isotopes of oxygen. One is your O816, another is your O817. Similarly, think about the isotope of chlorine. Here, chlorine having two isotopes, Cl1735, another is a Cl1737. Two isotope. First chlorine, that is your Cl1735. Your atomic number is your 17. Here also atomic number 17. Mass number is your 35. Your mass number is your 37. Your atomic number is same, but mass number is different. So there are two isotope of chlorine. One is Cl1735. Another is your Cl1737. If you think about the different physical property and chemical property of isotope, then remember each isotope having different physical property, but remember the chemical property of each isotope are same. Physical property of again I want to repeat, physical property of are same. If you think about the carbon having three isotopes. These three isotopes having different physical property. But if you think about the chemical property, then three isotopes are having same chemical property. In the upcoming class, I will clearly explain about the isotopes. Next, move to the isobar. Isobar means it is the opposite of isotope. In isotope, atomic number is same, but mass number is different. But here is the opposite. For isobar, you will think about the atoms having different atomic number, but the same mass number. Let me explain. Here I have given three example. Example is your argon 1840, calcium 2040. Look at that. Argon and calcium having the mass number, both having the mass number having equal, that is your 40. But if you think about the atomic number, here argon is 18, another calcium is a 20. So here I cannot say that mass atomic number for two. Here the for the two case, here I can say that argon 1840 and calcium 2040 are isobar to each other. Similarly, here I have given other example, that is your PB 82 to 82 210, Bi 83 210, and polonium PO 84 210. Look at that, here 210, here also 210, here also 210. That means here I can say that mass number for all the case is your 210. Means for all the case the mass number is the same. But if you think about the atomic number, here 82 is given, here 83 is given, here 84 is given. So here we cannot say that atomic number are same, atomic number are different. So these three species are isobar to each other. In case of isotope, we generally saw that they have different physical property but same chemical property. Same chemical property means you can think oxidation, reduction, like this. Physical property means you think about the color, structure. Uh, these are the physical property. But if you think about the isobar, you cannot say such type of point like the isotopes. Next, move to the isotone. What is isotone? As per the definition, each species having the same number of neutrons. If the atoms which possess the same number of neutron are called isotone. Are called isotone. Here I have given two example. One is chlorine, another is potassium. Look at that. If you think about the chlorine, that is 1737. This is what? This is your atomic number. This is your atomic number. This is called also number of proton. Number of proton. This is your what? Mass number. Mass number means you can think about n plus p. What is your n plus p? For Cl 1737, we can say that p is equal to 17. Or n plus p is your how much? That is your 37. If you will find out the n value, then put the value of p in this equation. Here I can say that n plus 17 is your 37. N is your how much? 20. 37 minus 17 is your 20. For Cl 1737, the n value is your 20. Now I want to check for potassium. If you think about potassium, that is your 3919. This is your n plus p. This is your p. Now you will find the n value. N value means you can say that like this. P is your, here we can say that n plus p is equal to 39. P is your 19. Put the value. Now I can write n plus p is equal to 39. Now find the value. N is equal to 39 minus 19. That is your 20. Look at that. For K 1939, the value of n is equal to 20. For Cl 1737, the value of n is equal to 20. For these two species, the number of neutron are same. So here we can say that Cl 1737, potassium 1939 are said to be isotone. Similarly, you will check the number of neutron for these two species. One is your carbon 613, another is your nitrogen 714. Let me try. Again, I want to verify the second example. Cl 613. This is your p value. This is your n plus p. Put the value of p here. Then I can write 6 plus n is equal to 13. N is equal to how much? 13 minus 6, that is your 7. This is your 7. Now check for nitrogen. Nitrogen means 714. This is your what? This is your p. This is your n plus p. Put the value of p here. Then I can write 7 plus n is equal to 14. Now n is your 14 minus 7. That is your 7. Look at that. For Cl 613, n value is your 7. For n 714, the n value is your 7. Both these species having same neutron. So here we can say that C 613 and n 714 are isotone to each other. Now move to the nuclear isomer. Atoms of radioactive element having the same atomic number and mass number but different in the radioactive property are called isomer. Look at that. If you think about the nuclear isomer, that is a cobalt 60, cobalt 60M. Both the having the atomic number same and mass number is also same, but the if you think about the radio property of radio property of cobalt 60 is not equal to the radio property of cobalt 60M. They are different in their radio property, but they are having same atomic number and mass number. So these two are said to be nuclear isomer. Cobalt 60 and cobalt 60M. These two species are called nuclear isomer. Similarly, you can check about uranium X and uranium Z. Here also atomic number and mass number That means atomic number of uranium X is same with the atomic number of uranium Z. Similarly, mass number of uranium X is equal to mass number of uranium Z. They are same, but the difference is the radioactive property. Uranium X do not have the same uranium X do not have the same radioactive property with the uranium Z. They are different in their radioactive property. So these species, that is your uranium X and uranium Z, are called nuclear isomer. Next, isosphere. There are two examples I have given. A is your carbon dioxide and N2O. Another is your N2 and CO. Let isosphere, molecules of different substance that have the same number of atom and same total number of electron and possess similar physical property are called isosphere. Look at me. Look at the question A. Carbon dioxide. Here the number of atom is 1 carbon plus 2 oxygen. That means 3, total 3. So here I can say that total number of atom is 3. This is the number of atom. Now think about the N2O. Here 2 nitrogen atom, 1 oxygen. Here also 3 number of atom. For carbon dioxide and N2O, the number of atom is your same. That is your 3. But if we think about the number of electron present in the carbon dioxide and N2O, then let me check. For total electron for CO2, carbon having how much? 6 electron. Oxygen having 8 electron. Here 2 oxygen atom is present, so 2 into 8. That means here I can say that total electron for carbon dioxide is your 6 plus 2 into 8. That is a 6 plus 2 electrons. Let me check for N2O. Here nitrogen having 7 electron, 2 nitrogen means 2 into 7. Oxygen having 8 electrons, so here I can write plus 8. 14 plus 8, that is your 22 electrons. Look at that. For CO2, the number of atom is 3. For N2O, number of atom is 3. That means both the species are same in the atomic number of atom. Here also carbon dioxide having 22 electron, N2O having also 22 electrons. That means the number of electron is also same. So CO2 and N2O are said to be isospheres. Molecules of different substance that have the same number of atom and same total number of electron possess similar physical property are called isosphere. So here I can say that CO2 and N2 are said to be isosphere to each other. Next, let me explain the second example. One is your N2, another is your CO. N2 means there are two atoms. CO means also two atoms. One is your carbon, another is your oxygen. That means total is your two atoms. N2 and CO having same number of atom. Let me check about the electron. Here two nitrogen atom is present. One nitrogen having 7 electron because the atomic number of nitrogen is just 7. So two nitrogen having 2 into 7, that is your 14 electron. Carbon having 6 electron, oxygen having 8 electron in CO, carbon monoxide. Now the total electron is your 14. Look at that. Here the number of N2, here the number of atom is same. Here the number of electron is also same in both the cases. So here we can say that N2 and CO, carbon monoxide, are isosphere to each other. Let me explain about the isodiapers. What is isodiapers? Atoms possess the same difference in the number of neutron and proton. That means n minus number of neutron n minus p, that is the difference of neutron and proton, must be same. Let me check. This is the problem. This is the A example. U92 to 38, thorium 90 to 34. This is your P. This is your P plus N. This is your P, this is your P plus N. That means for U 92 to 38, P is your 92, N is equal to how much? 146. Because 238 is the n plus p. Put the value of p. Already I have discussed in many times. So put the value of p, then you will find the n value. Your n value, that is n value is your 146. Your p, small p is your 92. Difference is your 54. 54 means 146 minus 92, that is your 54. Think about the thorium. Your p value is your 90, n value is your 144. Difference is your 54. 54 means n minus p is your 144 minus 90, that is your 54. Look at that. Uranium 90 to 238 having difference is your 54. Thorium 90 to 34 having also difference is your 54. Here the difference is same. So here we can say that U 92 to 38, thorium 90 to 34 are isodiapor to each other. Think about the another example, sodium 1123, magnesium 1225. This is a 20 for sodium, 23 is your n plus p, 11 is only p. Put the value of p here, we can able to find the value of n. That means for Na 1123, p is your 11, small n value is your 12, difference is your n minus p. So here you can say that 12 minus 11 is your 1. Think about Mg 1225. Your P, 12 is the P, 25 is the N plus P. Put the value of P here. Then you will able to find N is equal to 13. Your P value is your minus P. So here I can say that 12 minus 11 is equal to 1. Look at that, the difference for both the case, that is your Na 1123 and Mg 1225 having the same difference, that is your 1 1. So these are said to be isodiapor. These are the some nuclear structure. Isotopes, again I want to repeat in short manner. Isotope means atomic number same, mass number different. Isobar, atomic number different, mass number same. Isotope, number of neutrons same. Nuclear isomer, atomic number of atom, nuclear isomer means same atomic number and also same mass number but different in the radioactive property. Isosphere means same number of atom and same total number of electron. Isodiapor means the same difference in the number of neutron and proton. This is all about for this class. This class it is very vast. So I want to stay here. Thank you all for watching this video. Namaste.